Okay guys, so today our topic is about the logic gates. Before getting into the practical applications and the practical use, how they are being used in the breadboard, one should must know about the logic gates. What are basically the logic gates? So today the topic is totally based on the logic gates. Okay, a logic gate is a basic building block of a digital circuit that has two inputs and one output. So basically, not in all the gates, but generally in all the gates that contains two inputs and one output. There are some gates in which only one input is there and one output. The relationship between the inputs and the output is based on a certain logic that is different from the different gates. These gates are implemented using electronic switches like transistor and diodes. In practice, the basic logic gates are built using CMOS technology, FETs, and MOSFET. These are basically technology for which the gates are being built basically, but not getting deep into that. Okay, moving forward, logic gates are used in a microprocessor, microcontrollers, microcontrollers also in the electrical projects and electronics. Okay, there are basically seven logic gates, seven basic logic gates that are AND gate, OR gate, XOR gate, NAND gate, NOR gate, XNOR gate, and NOT gate. This is a general figure, but again I'm saying not for all the gates, because there is a gate in which there is only one input and one output. But generally we can say that all the gates, there are two inputs and one output, and the logic operation, it depends upon the gate which we use. Okay, number first is AND gate. So the AND gate is a digital logic gate with n inputs and one output, which perform logical conjunction based on the combination of its inputs. So it will tell how if the inputs totally depend upon the inputs. What if the inputs are zero, so how will it perform? So it's totally dependent on the inputs. The output of this gate is only true. So remember, it's only true when both of the inputs, there is a source, there is something to the input. If the input is zero, so it won't work. It will be the output of the gate would be zero. Ultimately it would be zero. Okay, the symbol and the truth table of an AND gate with two input is shown here. Here you see there are two inputs, A and B, and output O is there. Mathematically we can write it O equals to A product multiply with B. See here the truth table. When both of the gate are zero, both of the inputs are zero, the output is zero. When one input is zero, one is there is one, which means there is presence of some source. So again the output would be zero. Again, if there is an input, which means there is some source, and with the other input there isn't any source, so the output again would be zero. But if they are both of the input have some source, so then the output would be 1. Okay, OR gate. The OR gate is a digital logic gate with n inputs and one output that performs a logical conjunction based on the combination of its inputs. The output of the OR gate is true only when one or more inputs are true. If all the inputs of the gate are false, then only the output of the OR gate is false, which means that if there is only one input have a source, so the OR gate output would be 1. Okay, let's see the symbol. It's totally changed from the AND gate. See, again there are two inputs and one output is there, and mathematically O equals to A plus B. Looking towards the truth table, see, no, there are no inputs, so the output is 0. But if there is one input, at least one, so then the output is 1. See, one input is 0, but other is 1, output 1. One input 1, other is 0, output is still 1. And if both the inputs are 1, so still the output would be 1. Here see, 1 plus 1 is basically 2, but we have binary digit. 1 plus 1 doesn't mean here that we will write 2. 1 and 0 basically tells about whether the light or the LED will blink or not. 0 means it won't, but if there is 1, so it would blink. Okay, so basically it's not that if we will add 1 plus 1, it will give us 2. Remember, these are binary numbers, and in binary there are only 0 and 1. 0 is basically for false and 1 is basically for true. Okay, the next one is NOT gate. The NOT gate is a digital logic gate with one input and one output that operates an inverter operation of the input. The output of the NOT gate is the reverse of the input. When the input of the NOT gate is true, which means 1, then the output will be false, which means 0, and vice versa. By using this gate, we can implement NOR and NAND gates. Here is a symbol of the gate. See, here is only one input, only one input is being there, and output you see. So it's totally, if the input is see the mathematical formula get that, and the table. If the input is 0, so it will give us 1, but if the input is 1, it will give us 0. Okay, the next one is NAND gate. The NAND gate is a digital logic gate with n inputs and one output that performs the operation of the AND gate followed by the operation of the NOT gate. NAND gate is designed by combining the AND and NOT gates. If the input of the NAND gate is high, then the output of the gate will be low. High means 1 and low means 0. Okay, see the symbol of the gate and the mathematical here equation for that. A product of B, and it will be inverted there. Okay, if see, if both of them are 0, the inputs of both of them are 0, 0 multiply 0, it's 0, but it will invert, so the output would be 1. 0 multiply 1, again it's 0, but it will invert, so for that reason it gets 1. 1 multiply 0, it's again 0. 1 multiply 0 means that there is one input gets a source and the other input doesn't get a source, but still it would give us an output with 1, which means it will give some output to us. 1 multiply 1, it will get us give us 1, but this gate, it will totally invert that. The NAND gate will totally invert that, and it will give us 0 output. Next one is the NOR gate. The NOR gate is a digital logic gate with n inputs and one output that performs the operation of the OR gate followed by the NOR gate. NOR gate is designed by combining the OR and NOR gate. When any one of the inputs of the NOR gate is true, then the output of the NOR gate will be false. Okay, here it is the symbol of the NOR gate. See, and here it is the mathematical equation of the NOR gate. Looking towards the truth table, if both of the inputs are 0, so 0 plus 0 it's 0, but it will invert that and it will give us 1 output. If one input is 0 and other is 1, still it becomes, by mathematically it will give us 1, but as it's a NOR gate and it will invert that, so it will become, the output will become 0. So which means basically in this from this truth table, it shows us when both of the sources are 0, so it will give us some output, and it will give us some output. Okay, next one is the exclusive OR gate. The exclusive OR gate is a digital logic gate with 2 inputs and 1 output. The short form of this gate is XOR. It performs based on the operation of OR gate. If any one of the inputs of the gate is high, which means 1, then the output of the XOR gate will be high, which means 1. Okay, the symbol of the XOR gate is shown, and see the mathematical equation for that. Inputs, and both of the inputs are 0, which means there are any source, so the output will be 0. If one is 0 and 1 and the other is 1, which means there is some source, so it will give us 1. If one is if there is some source and other there isn't any source, which means if one is 1, one input is 1 and the other input is 0, so it will give us an output which is 1. But when both of the inputs are 1, so which means there are some source connected to both of the inputs, it will give us 0 output. So from this truth table, this shows that if both of the inputs are either 0, which means no source, or either 1, which means a source, so the output would be 0. If one input is 0, which means no source, and one input is 1, which means a source, then the output would be 1. The next one is the exclusive NOR gate. The exclusive NOR gate is a digital logic gate with the 2 inputs and 1 output. The short form of this gate is XNOR. It performs based on the operation of NOR gate. When both the inputs of these gates are high, then the output of the XNOR gate will be high. But if any of the input is high but not both, then the output will be low, which means 0. So this one is totally the inverse of the gate which I've told uh, previous. Okay, the symbol and the truth table of the X node are shown below. It is the symbol of the X NOR gate. See the output and then the mathematical equation of this. When both of the inputs are 0, which means no source, then it will give us an output, which means 1. When one is 0 and other is 1, so it will give us 0 output. When again, if one input is 1, and which means the source, and the other input is 0, which means no source, it will give us 0 output. But if both have and so both of the inputs have a source, so it will give us one output. So basically from this truth table it tells that if both the inputs are 0 or either 1, then the output would be 1, or if one is 0 and one input is 1, so it will be the output would be 0. Okay, here are some of the use of the logic gates. The application of the logic gates are mainly determined based upon their truth table, that is their mode of operations. The basic logic gates are used in many circuits like a push button lock, light activated, burglar alarm, a safety thermostat, an automatic watering system, etc. There are many other use of the logic gates too. Thank you for watching. Our next video will be according to the practical applications of the gates in the breadboard. Thank you for watching. Please subscribe to the channel. Thank you.